In this video, I wanted to add a little bit more to my claim that the non-local and or superliminal route was probably the best response to the dilemma established by Bell's theorem, or at least just given the evidence from Bell's theorem, because there's lots of reasons why you might want to be a non-determinist too, but they come from other areas of quantum theory. Anyway, the two things that I think are also relevant here is that relativity theory, including the constancy, is known to be a domain-limited theory about reality. Why is this? Well, there's basically results showing, and this is why they think nothing may exist beneath the Planck length, although there's also lots of other explanations, that if we take generalizations of the uncertainty principle, kind of some of the results that have been built on top of it, and we combine it with laws of relativistic gravitation, we actually get rules about the uncertainty of density of objects beneath the Planck length, where if they had any mass or energy, we can't be sure whether a specific field of space was completely sparse or so dense it would produce black holes. And that both means we couldn't theorize about it, as well as if both relativity and quantum theory applied here. Yeah, if both relativity and quantum theory applied down here, then reality probably wouldn't exist, because that's a level of uncertainty that couldn't form anything. So any theory involving superliminal information transfer might have sub-Planck interactions as the ultimate mechanism. There's an area of reality already carved out for use. The problem is this is not very scientific, because we're probably not going to be able to observe this far down ever. And that is a huge issue, although it's an issue with things like string theory and multiverses as well. But the second thing is, although they say there's nothing like superliminal information transfer in modern science, when you get into kind of QED and quantum field theory, they use particles called virtual particles in calculations law in order to model them, and they are modeled as things going faster than the constant c. Although interestingly, they're modeled as things going faster than the constant c that sometimes behave as relativity would expect and sometimes not. Some of these move backwards. The really interesting thing here is this is very similar to the debate over whether or not electrons are virtual mathematical entities or real particles. Electrons were so strange to physicists that they thought for a very long time, this was the vast majority of physicists, that the electrons must not be real and must be some sort of mathematical formalism. That's what physicists claim about virtual particles, but from my perspective, which I have to understand things mostly based on philosophy of science and history of science. Since I'm not a professional physicist, I'm very skeptical, from what I know of the development of science, that it's a really obvious thing that these virtual particles are not real, especially because, they do even have behavior that would be like a real particle traveling faster than the speed of light. But they're trying to do without these entities in the mathematics, and for some of the equations they can, for some of them they just haven't been able to get rid of them. And as long as these things are indispensable, I don't think it's clear whether or not we should be holding to the constant c everywhere in physical reality anyway.